Hi, I'm Konstantin. I'm one of the co-organizers of the AI in Cities track, together with Shin, I think he's sitting over there, and Nick Jones, who I don't know where he is. But yeah, and I have the pleasure to present you a little bit of the outcome from what we've done yesterday. So we started the track with a very broad introduction and a discussion about AI in cities. So the question we really posed is, how has AI already affected and will affect urban living, and what are the challenges, what are the opportunities? And so for our panel, we could get three amazing speakers, really. We could get Valentine Godard from the AI Impact Alliance, an NGO focused on AI ethics. We could get Stephen Goldsmith, who is a professor at the Harvard Kennedy School, where he teaches, amongst other things, mayors from around the globe. And he's a former deputy mayor of New York and mayor of Indianapolis. And we could get the pioneer of computational social science, Sandy Pentland. And really, from that discussion, the main points that at least I got were that AI has to be implemented in a very participatory way, together with the citizens to work out well. The right metrics are important. So how do you evaluate the success of any AI system, and who sets those metrics? AI can be both harm and helpful. If you think about predictive policing, this can be a very harmful thing. If you think about predicting which building might be a fire threat, that's a very, very good thing. And overall, AI is not yet capable of really representing the very complex urban environments. So after that first discussion, we had a series of short spotlight talks that kind of highlight research and companies who do stuff with cities. Christina from ETH Zurich told us about crime mapping in cities and how different data sources can be used together to predict crime. Danielle from EPFL told us about participatory approaches to AI in cities. So how can people take part in labeling areas in cities with their own subjective labels to help us understand more about cities? Sandy told us about a startup that is using encrypted data with AI together. Piotr from DeepMind told us about how they trained autonomous agents using urban environments to navigate through cities. Christopher and Niklas from two startups told us about their approaches to urban data science and how that can be made into a business. And lastly, Mohammed from Swisscom told us about how Swisscom uses large-scale machine learning. So please check our website of the track if you are interested in any of these themes. You can find all of the speakers. Reach out to us if you want to continue the conversation. Thank you very much.
Thank you. So the next one is AI and computer systems.
Hi. So we ran the AI and computer systems track, and we talked about the present and the future of computer systems that do AI. So in the present, we presented, the first talk was talking about building ML microservices for IoT, and we also talked about building libraries to identify and mitigate adversarial attacks for ML systems. When we talked about the future, we actually went and we talked about what is going to happen with these systems in the future, how the accelerators are going to be affected. And one prominent accelerator is FPGA. So we talked about how are FPGAs the solution for ML, or should we actually move on to another solution, ASICs or something like that? The second problem is, how do can we actually, these ML models have very nice numeric properties. Can we actually take advantage of that? And is that a fundamental issue, or is that just like something that academic scientists like to do for fun? And the final thing is like, what happens after digital ML? So if we start developing analog systems, can we make them usable for people, or is it going to be like making it hard for people to adopt ML accelerators? I would like to thank all of our speakers, Andreas, Michael, and Hari. They were talking about the future of these systems, and Kevin and Svetlana that were talking about the present. I would also like to thank our audience. They had some great questions, and they really participated, and it was really interesting. Thank you very much.
Thank you. And the next one is AI and environment. This was a full-day track.
Yes. So just go. Hello, everyone. So yeah, my name is Alina, and we organized this track in a committee that was people from ETHZ, EPFL, University of Lausanne, and Oxford. So we had the honor to have a full-day track here on AI and environment. And as this is such a broad topic, we split it into 4 subtopics. So yesterday we had a session on remote sensing and biodiversity, and this morning, we tackled the topics of sustainability, energy, and climate. In yesterday's session, we saw some impressive examples of the use of machine learning to predict crop yields, to monitor landslides and land use, and to model the migration of species. And afterwards, we had a panel discussion with all our experts who highlighted some of the key challenges in the field, which is mainly bias that we find, especially in biodiversity observations, because we have, for example, much more data in the US or Europe or Asia, but nothing really in Africa or South America. We have a lack of label training data, which is, of course, important if you want to train a model. And there's also the problem of interpretability of the models and really understanding why things are happening the way we see. This morning in our session, Energy and Climate, we saw some examples of modeling of energy use or energy demand, energy generation, life cycle assessment, and also the improvement of climate models using machine learning. So here, really often, we have actually not alone standing machine learning models, but instead we see examples of machine learning being integrated with existing physical models. So what is extremely important here, what our speakers highlighted in our second panel discussion, is to understand patterns in the data and to have a feeling for what we're actually modeling before we start putting it into a machine learning algorithm. And well, a bit of my conclusion of the thing is the role here for machine learning to build bridges between existing physical models and the data that we have and all the observations that we collect these days. So yeah, I would like to thank again all the speakers we had, the entire organizing committee, also the conference. It was really great. And if you're interested in any of these topics, please have a look at the track website. There's all the details of the speakers. I didn't detail them now because we had so many, but they were really great talks, and thank you very much.
Thank you. All right, the next one is AI and finance.
Hi, hello. Well, so my name is Michael Noguer. I led the AI and finance track this morning. Right, we had the opportunity to discuss so all this that you are well aware of. Right, so we discussed how artificial intelligence can be used in finance. We discussed some user cases. We discussed algorithms. We basically said that if you look at this, it's basically machine learning, artificial intelligence can be useful everywhere, right? It's hard not to find a place in which natural language processing or machine learning can be used, right? For example, we mentioned things like 80% of financial markets data information, it's not about numbers, it's about text, right? So imagine the potential of sentiment analysis and natural language processing. We had 3 fantastic speakers. We had Armando Gonzalez from Ravenpack, one of the leaders in big data and in finance, and he mentioned, right, something like that is obvious that there's no good AI without good big data. We also had Peter Colm from NYU who spoke about reinforcement learning, so something that it can be very, very useful for finance. And we also had Charles Lehal from Capital Fund Management who spoke about execution algorithms, and also something very interesting, which is how also machine learning can help humans to interpret machine learning inputs, right? So machine learning give us big data, artificial intelligence give us the access to really digest a lot of stuff, right? And humans also need or might need artificial intelligence to do that. So the open issues, as everyone has been pointing out, right? So finance is very special, right? So to speak, user case, because we have so much noise. We have obviously a large data privacy issues, so those are things we need to take care about. Otherwise, we can do a lot on this, for example, on the second point, like learning from experience, multiple agent instruction, we have sparse rewards, we have everything that relates to financial markets. It's obviously explainability, interpretability, and fairness are, as some other speakers pointed out. So thank you very much. I think it's been a very interesting experience, and thanks all for coming.
Thank you. All right, the next one is AI and health.
Thanks, Marcel. There you go. Yeah, this was co-organized with Marcel. We had some great speakers, and it was great to see that every part of the healthcare industry was represented. So I think what was good to see that doctors were actually collaborating with machine learning practitioners. And more importantly, I think we actually had 3 doctors in the room, which may seem few, but it's a start. But more importantly, there was about 75% of the people in the room who had actually collaborated with clinicians. As again, interpretability is really important when it comes to these models, which is actually inhibiting adoption, and people prefer linear models over deep learning models. The community needs to collaborate with regulators. We had a talk on that and how important that was to empower faster adoption of these technologies. ML can help in intervention. There was some cool projects about brain-computer interface and how we can use that for language therapy and getting recovery from stroke. Machine learning being used at Roche actually on clinical trial design and identifying target participants. So three main aspects, I would say. So medical imaging. And it's actually good to see we had multiple examples where stock CNNs with pre-trained weights that were actually just on ImageNet were getting really good results to start with. And people are modifying that. But more importantly, you're getting good results just with models that are available for anybody to be used. So with EHR and or EMR and clinical notes, this data is rich. CNNs and RNN architectures are being used with great effect. Even with longitudinal data in EHR system. Last, we had really good stuff about population health, using location data and search history, predicting food poisoning and the cause of it. There was also cases where you could actually prevent epidemics and inform cities even before it actually becomes an epidemic. Location data and pop health data and satellite imagery being combined, really interesting research from Boston University on identifying obesity with neighborhoods with obesity. So really, really good coverage, and thank you to all the speakers of the track. Thank you so much.
Thanks, Sunil. All right. Thanks very much. The next one is AI and industry, which was also a full-day track.
Okay, so we were discussing industry and AI, and in this track, I think it was quite clear that the Applied Machine Learning Days, we are not a scientific conference purely, and we are also not the typical business conference, but we are really at the interface of the two, and in the industry track with many of these companies which you had here, which were sharing experiences between researchers and practitioners in many of these large and small companies. We had great exchanges and 33 speakers who will hopefully stay in touch and had very interesting talks. And
Right, so it was a dazzling experience with this many talks. Two of the highlights were the panels that we featured. One of them was is depicted here. You see that there were 5 discussants, 3 of them women and only 2 men. So this bodes well for our field, I guess. And on the other day, we had a conversation that featured Alex Lebrun, who is a serial entrepreneur, French guy, but he had founded companies also in California and has experience with Y Combinator and so on. So he dropped some substantial wisdom on this stage, I would say. For example, one nice insight was that if you have a startup and you receive a call from Google or Facebook and they ask you if you want to sell your startup, then you shouldn't be that happy. You should actually start to be worried, because chances are that they sniffed out that you're in a bad situation and might be willing to sell for cheap. So that was a nice takeaway. But obviously, industry is a core ingredient of this conference, so we were super happy to have such a crowded industry track. Thank you.
All right. This says learning analytics. My Slack says language. Let's see. Are you learning analytics? Excellent, then let's do that. Thank you very much.
Hello, so I'm Jennifer Olson. I'm one of the co-organizers for the AI and Learning Analytics. And at the core of this track, we're really thinking about the activities that students are doing, the data that comes from those, and then how we can use that data to better support them, and so how we can build models around their learning, and then we can use that to personalize and adapt to them. However, in this track, what we saw was that we really have to think about the context as well. So it's not just the models we're building, but what is the curriculum that we're trying to build these models around, and how does that introduce bias into our models, and what does it mean for the domains we're working with? But also what data are we starting to collect? So for that, some of the data can provide us with information that humans can't get themselves, but we also have privacy concerns when we start to collect data about students and potentially are keeping that for their entire lives. Then we want to think about where we can start to use these models as well. So where are the opportunities where we can put them into either the workplace or school, and to really support learning in these different aspects, and start to bring them from just individualized models, but thinking about also the social context as well. Now, on the other hand, after we sort of have these models, we have to think about how we're distributing them as well, right? Are they interpretable? How can we give them to people? Are they students? Are they teachers? And when we think about that, how are we actually giving them the information? Should we be giving them visualizations, or do we give them recommendations? And then finally, what we want to think about is really closing the loop. It's not just enough to build a model that's going to be able to match our data and predict it well, but can we then put that back into the learning situation and actually see learning gains with the students?
Thank you, Jennifer. All right, I just want to make sure we didn't skip any slides. No, we didn't. Okay, so and now it's AI and networks. Just one.
Hi, I'm Lorenzo Gronai. I'm one of the co-organizers of the AI and networks session. Networks here means computer networks. So it was a track mixed between academia and the industry, and there were a lot of diverse point of view on machine learning, artificial intelligence, and what we can do for networks. What I'd like to highlight is that, okay, computer networks, they are essential to our daily lives, are critical for most of the business, and we have almost all the data that we have are crossing a network. So operating a network is extremely complex, and it's getting more and more complex, and it's getting more and more critical not to have downtime. So we have a huge amount of data, which is a nice problem to have for machine learning. We have actually too much data. And this, on one side, enables to use machine learning and AI, and on the other side, it makes it extremely needed, because it's getting more and more difficult to use heuristics or to use, well, people working on this. because of the complexity and the speed of data and the need of real time and the atypical kind of data, there is need of new machine learning. And this is happening. We are at an early stage, but it's already started happening, and it's a great opportunity to explore and to have a real deep impact, both for the network themselves and for other applications that wants to use the data that comes outside of the network. And I'd like to thank all the speakers and all the panel. That was, I think, a very active discussion. Thank you.
Thank you. All right, AI and language. You have slides?
Hi, I'm Adam. I organized AI and language. So there are just a lot of shiny new tools since, let's say, 5 years ago when everybody was using NLTK. And a lot of people are asking, in AI in general, in ML in general, right, is all of this good for the little players or is this good for the big players? And all of the little players there said, no, this is good for us. We can do a lot more than we could have ever done 5 years ago, being sort of outside of one of the giants. So, and there has been, of course, all this amazing progress with word2vec, sec2sec, and so on. But language is hard, right? This totally fools almost any machine right now, unless you have specially, done some tricks to make it handle this. And all of you are totally fine with it. Little children are fine with it, right? And language gets sort of at the core of what human intelligence is. It's something that other species don't have, unlike flying and grabbing and so on. And you heard a little bit about this, right? Even Kasparov talking about the difference between chess and Go, and you can do the math. There's a branching factor, so we can prove this, right? I won't get into it now. So it is harder. So then, and the other point is that there's not just one language, and we should keep reminding ourselves of that. And it drops off very, very fast. It's like a good analogy might be Google Maps, right? Once you leave, a few corners of a few developed worlds, it all breaks down very, very fast. All of our modern technology. And so, talking about solutions, more context inputs, this is a big one. This means, right now, a lot of times we are not making a decision even on the, even using the previous line of input to answer a sentence or to translate a sentence or something like that. It may not just be text input. We heard even about voice, intonation of the voice might help with our sentiment classification, right? So we don't just turn something to text, we also keep the sentiment there. Better representations, not just vectors, word2vec, unsupervised approaches for all that unstructured data, and just really focusing on the problem, really having deep intuition and knowing what the pain points are. So, thank you.
Thank you. Thanks very much. All right, AI and transportation. Thank you.
Hello, everyone. I'm Alexandre Alaï, one of the co-organizers of AI and transportation with Michel Birler. We had a great track, a nice mix of keynotes from academia and industry, as well as spotlights from multiple great speakers. It was interesting to see that in academia, we had talks on how to predict demand in transportation systems, how to predict human behavior, traffic human behavior for self-driving car. And from industry, the interesting part is they were also looking at the same problem. For instance, how to address self-driving car if you don't have enough labels. How can you use self-supervised learning? How can you use domain adaptation? And the same topics that we in academia are studying, supposing we don't have enough human power to solve this problem. And we had a fantastic session where some professors were also sharing the existing challenges that we need to solve in self-driving car and some of the recent progress. On the spotlight session, we had presentation from Amazon, their little car to do work on reinforcement learning. We had a nice talk on how to do routing problem for other applications than self-driving car or delivery. How to use AI in elevator, the vertical transportation problem, and how we should think about humans when we have autonomous moving agent in the space. And finally, how to use reinforcement learning to do scheduling or planning or controlling train systems at SBB. Thank you very much.
Thank you. All right, and last but certainly not least, AI and security. Thank you. Slides?
That's one slide.
That's one slide, okay.
One slide. Yeah, hello everybody. I'm Teresa Jovciu. I come from Hamburg. I chaired the AI security track. It was part of the trust session, together with privacy and AI for good and trust. I had also quite a diverse mix of speakers from academia and industry and startup, but all of them mostly research. So fortunately, you can read all their work in publications if you didn't make it. Unfortunately or fortunately, there was not much lack of consensus. So everybody agrees we need security in machine learning and in AI, and it's not enough. So so we had Nicolas from Google Brain and El Mahdi from EPFL, PhD student. He already found the bug in some machine learning models here, presented here from big names. And we had Mihaela from DeepMind and Raul, who has a startup in cybersecurity, and he offered his help to help anybody who needs help to start a startup in cybersecurity. He also said, this is the time to start a startup in cybersecurity. And Mohanty, who presented the crowd AI. Okay, done. Thank you.
Thank you very much.